Hello friends, welcome to Shiksharthi. In this video, we'll be talking about 3D geometry, and under the head of 3D geometry, we'll be talking about cubes and cuboids. So let's start. So now the objective for this session is we'll be talking about cubes and cuboids, and we'll be broadly dividing this session into two parts. One is the mathematical angle in it, and the second part is the logical reasoning or the analytical reasoning aspect in it. So starting off with the mathematical angle. Okay, so now when we talk about the mathematical angle, for further discussions, if I'm using SA refers to surface area, VO refers to volume, LSA is the lateral surface area. All these terms I'll explain it to you. TSA is the total surface area, and so on. So now when we talk about either cubes or cuboids, can we put it like this, that whether it is a cube or a cuboid, it is a kind of prism. The first point to be understood here. The first point to be understood here is, can I say that both of these, which we are talking about cubes and cuboids, are both of these, or can both of these be put under the head of prisms or not? So for this we need to understand the definition of a prism. So if I say yes, they can be put under the head of prisms, that means prism basically, resurrecting the basics, how we will talk about here is, basically before 3D we talk about 2D. So when we are talking about 2D refers to two dimensions. So two dimensions is, let us understand, either we are talking about x-axis, we talk about x-axis and y-axis both. So x-axis and y-axis both is when we talk about 2D. But when we talk about 3D, we talk about the x-axis, we talk about the y-axis, and then we talk about the third axis, which is known as the z-axis, wherein the concept of 3D comes into picture. So let's put it like this: if I take any room, a room will either be a cube or a cuboid. So when we are talking about three axes, let us try and see. For example, if I say that this is a room, the room in which I am conducting this session is a room. So you will see that if I just see the edge, this edge if I talk about. So this edge meets another edges. So let's say this is one of the edge, this is another edge, and this is the third edge. They have the same point of meeting. So three edges will meet at a point, and that point is known as the vertex. Now when we are talking about these three edges, let us try and understand that this is just like saying x-axis. Now the other edge on the same plane. Now this is the same plane. So if I talk about the room is the same plane. So now if I talk about this point B. So point B, there are how many edges which converge at point B? So one edge is edge AB, the other edge is BG, and the third edge is BC. So now when I talk about the same plane, this is the same plane. So AB and BG are the edges which are lying on the same plane. So let's assume that this is my x-axis, this is my y-axis, and in that case this becomes the z-axis. Okay, these are relative terms. You can always change x, y, z, you can intermingle. Okay, so now, 2D has only two dimensions. So when we talk about two dimensions, basically two dimensions are length and breadth only. When we talk about three dimensions, we talk about length, breadth, and the height. So this is the height. So as we were talking about, AB is one of the edge, BG is another edge, and BC is the height, the edge which represents height. Okay, so can we say that cube or cuboid is a prism? Yes, we can, because what is the definition of a prism? The definition of a prism is the faces or the sides. Now the word side or sides is used only with respect to two-dimensional figures. And the moment we talk about three-dimensional figures, this terminology changes to faces, face. For example, I am a 3D figure. So when I'm talking about my face also, now I can talk about any face. So the face of this is the face. Here, this is the face. Okay, so now when I talk about this cube or a cuboid, I mean the shape will be more or less the same. So unless somebody tells me that all the edges are equal means they have the same length, till then the appearance may be deceptive. I mean, I cannot assume that this is a cube unless somebody tells me that all the edges. So how many edges a cube or a cuboid has? 12 edges. How many faces? 6 faces. How many vertices? 8 vertices. So the definition of a prism is the faces, the lateral faces that we talk about. What are the lateral faces here? So as I have written it here. So what are the lateral edges? The lateral edges will give rise to the lateral face. So the lateral face is not the top and bottom. So excluding the top and the bottom, the remaining faces are known as the lateral faces. Lateral. And how many edges will make lateral faces? 4 edges. And how many edges will make the top face? 4. How many edges will make the bottom face? Again 4. So how many total number of edges? 12. This can be divided into 3 parts. 3 parts are, we are basically talking about 4 top edges, 4 bottom edges, and 4 lateral edges. This is a point that you need to understand. Similarly, when we are talking about faces, the faces will again get distributed into 2. How? Now this gets distributed into 2. So I'll say this is 4 plus 2. This is how much? 4 plus 4 plus 4. And this 8 can be understood as 4 plus 4. Now what am I trying to say? I am dividing this entire discussion into lateral, top and bottom. So how many lateral faces does a prism have? That is dependent on the top and the bottom. That is dependent on the top and the bottom. For example, I can put a hexagon also here. So if I put a hexagon here, then the number of lateral faces will be decided by the number of sides the hexagon has. Since I have either put, now this A, B, G, F can either be a square or it can be a rectangle. Now whether it is a square or a rectangle, it in any case is going to have 4 sides. So 4 sides of these will give rise to 4 lateral faces. So this 4 plus 2 is nothing but, this is 4 plus 1 plus 1. So when I say 4 plus 1 plus 1, 4 lateral faces, 1 top face and 1 bottom face. Similarly here, if I am talking about 12 edges and I am dividing it into 4 plus 4 plus 4. So what are we saying? We are saying 4 lateral edges, 4 top edges and 4 bottom edges. And when we are talking about the vertices being 8, whether it is a cube or a cuboid, then we are basically talking about 4 top vertices and 4 bottom vertices. There is nothing like lateral in terms of vertices. I hope this point has been understood. So this was talking about the reasoning part of it, or I mean you can say maths and reasoning. It's very difficult to separate them. I mean you just can't separate, they go hand in hand. Now talking about, if I say divide this discussion into these 2 parts, because in this video we'll be talking only about these things. Okay, so now when we say, so have we understood that cube and cuboid is a prism? Yes. And what is the definition of a prism? It will either have rectangular faces, the lateral faces, or it will have square lateral faces. And the number of lateral faces is decided by the figure which is attached at the top and the bottom. If the figure which is attached at the top is a 4-sided figure, then the number of lateral faces would be 4. If the figure attached at the top is an n-sided polygon, then the number of lateral faces would be n. Right? So the second point here is, second point to be understood, n lateral faces, L lateral faces, LF, for an n-sided polygon which has been attached at the top or at the bottom or both. Okay. So now if I talk about a cube, so can I say, if I'm talking about a cube and if I have divided this into 3D, which is, this is the length of this edge, which is HC, is X, the length of this edge, which is AH, is Y, and if the length of HE, the edge HE is equal to Z, in that case I have to specify that for a cube the length of all these three edges, if it is equal to this, is equal to a number which is, let's say, A, the length of the remaining edges will also become equal, right? Okay. Now what is a lateral surface area? Since we know that we know that for every surface it becomes 2D when you're talking about a surface area. So surface area for every face of a cube is A square. And how many lateral faces do we have? 4. So the total lateral surface area comes out to be 4A square. What is the top and the bottom surface area? A square for the top and A square for the bottom, which makes it as 2A square. So what is the total surface area? 6A square. Okay. Now what is the volume of a prism? We are basically talking about a prism. What is the volume of a surface? I mean the surface area of a prism. The surface area of a prism would be the lateral surface area, right? Plus the top area plus the bottom area. So this in generic becomes the surface area of a prism and the volume of a prism. So volume of a prism here is what? The base area into height. So when I am calculating and I know that cube is a prism or cuboid is a prism. So what is the volume? What is the base area? The base area is, we are basically talking about the base, which is a square, HEDC. Now the area of a square is A square and the height also is A. So A square into A comes out to be an A cube. Similarly, when we talk about a cuboid, we know that for a cuboid, at least one of the dimensions, at least one of the dimensions need to be unequal. For a perfect cuboid, all the three dimensions should be unequal. So I am taking a perfect cuboid wherein all the three dimensions are unequal. Okay, so in that case, the lateral surface area, now we know that the lateral surface area, we are having what? We are having 4 lateral surfaces, whether it is a cube or a cuboid. So when I talk about this, I am talking about this square, FGDE. So we are basically talking about which component? We are talking about the X component, at the same time we are talking about the Y component. And how many such? So this and the one at the back, which is ABCH, makes the total surface area as 2XY and plus 2YZ, because we will be having AFEH along with BGDC, right? They will be having equal surface areas. So which is why the lateral surface area comes out to be, now substituting, because we have assumed that the value of X is L, which is the length, the value of Y is the height, which is H, and the value of Z is nothing but the breadth. We have assumed this. Similarly, we have found out the volume and the total surface area. So now this discussion, so if I'm able to have some ingredients of reasoning in mathematics, as I've always been saying, mathematics becomes very interesting and the learning becomes exponential. If you feel that whatever has been discussed today enhances your knowledge base, please like the video and do not forget to subscribe to our channel. If you have already done so, select the bell icon and select what? All, so that you start receiving updates from us regularly. Thank you so much. Until next we meet, goodbye.